All right, so we can do just direct substitution when we're dealing with polynomial functions, when we're solving for limits. So essentially, we can get a limit by just plugging in the number, substituting the number into the function, provided that it is a polynomial. And the reason for that is that a polynomial is continuous, so you don't have any of those breaks or asymptotes or anything like that. It's a little trickier when you've got a quotient. So if you're looking at a rational function where you have a polynomial over another polynomial, you can do it unless you get a 0 in the denominator. If you don't have a 0 in the denominator, then you're good. If you do, there may be some more work to do, and I've got a couple problems that'll show you how to do that. First, let's use that just a normal polynomial. 4x squared minus 1 is going to be continuous, so I can just substitute the 2 in. So this equals 4, not 2, 4 times 2 squared minus 1, which is 16 minus 1, which is 15, and that's going to be our limit, and that's it. Similarly, 91, this equals 2 minus 7 times 1 over 1 plus 6, which equals negative 5 over 7, and we're done. The problem comes in with the next two that we have. All right, so if we just immediately substitute in the 4 into the denominator, in fact, both of them, both numerator and denominator, we get 0. 16 minus 16 is 0 in the numerator, and 4 minus 4 in the denominator is 0. So we've got a problem. But there's ways to fix this. So this actually equals the limit as x approaches 4. We have an x squared minus an a squared. 16 is 4 squared, so this is actually x minus 4 times x plus 4. And now I'm able to just cancel. Oop, and I canceled wrong. I can cancel these two. So that gives me the limit as x approaches 4 of x plus 4. And now we can just substitute in, so that's just 4 plus 4, which is 8. All right, 96 gives us a different way to solve this. Take a look, we put a 0 in the denominator, it's a 0, we're bad, and it's going to make a 0 up top as well. But if I just distribute this, so this equals limit as h approaches 0, 1 plus h squared is 1 plus 2h plus h squared, and then we have a minus 1 over here. Well, the 1's cancel, and I can factor out an h. So I have an h. So again, these cancel. So I factor out an h, and I'm left with 2 plus h multiplied by that, and I've got an h. Now I can do another cancel. And that leaves me with limit of h approaches 0 of quantity 2 plus h. And that equals just 2. When I put in a 0 for h, it goes away.